this question is the exploration question, and it's going to lead us into the criteria for similar triangles. This is actually more fun. I'm sorry I have to do this in a video because it's actually more fun to let you figure this out on your own, and then you come back to this video. But if you would like, you can pause now and read about it, and then come back when you're done. It is okay. It will only take about 5 minutes for you to read this and try it out. You go ahead. You can pause if you'd like. I'll be here. Okay, I'm back. Examine the figure and answer the questions to determine whether or not the triangles are shown are similar. So what information is given about triangles in figure 1? So if you look at this figure 1, so I just read the instructions and now I'm looking at the given image and the given figure, and I'm just scanning for details, like every good detective scanning for details, right? Okay, so we have lengths of A and B, we have lengths of B, B prime, we have length A and C, and lengths C to C prime. So to me, it says AB is equal to 4. It says AB prime, that's this whole length. AB prime is this whole length. That's equal to 13. We have AC, which is equal to 3 units, and then AC prime, which is equal to 6.75 units. Nope, that is, you see, nope, it is 3 plus 6.75, so that's 9.75. All right, what else do we know about this? We also know that this angle A, I see 2 triangles. I'm hoping that you see 2 triangles. Do you see 2 triangles overlapping each other? Angle A is equal to angle A. That's the reflexive property. We talked about that in a previous unit. Okay, part B. So this is just all the given information. That's all I have. I don't know anything about this B prime C prime line. I don't know anything about this BC line. I don't know if they're parallel. I don't know that yet. So how can the information be used to determine whether, sorry for the whistling again, whether triangle A, B, and C is similar to A, B prime, C prime? If we, whoa, this is going to be ginormous. If we prove the corresponding sides are proportional, then the triangle is similar, or it's just a dilated version of the other triangle, or it's proportional, or it's similar, or it's dilated. All those are the same thing, right? So our goal is to prove that the sides are proportional. So our goal is to prove that the length AB, let's do the larger image over the smaller image. I'm pretending like this is a one small triangle dilated to a big triangle. So I'm going to put the final length over the initial length, and then the final length, the larger length in this case, over the initial length. Okay, all right, I like that. Now, if this is true, we're not actually sure if this is true yet. If this is indeed true, then we will know that the triangles are similar. So let's see, AB, can I move this? Can you move? Thanks. Literally just, yeah, sure, you can go there. All right, let AB prime appear. So let's see, is 13 over 4 equal to 9.75 over 3? So if we divide 13 by 4, we're going to get, I guess we can take out a calculator. 13 divided by 4, 3.25. 3.25. Is that equal to 9.75 divided by 3? So 9.75 divided by 3. Let's see. We're going to hit enter. All right, 3.25. So what does that mean? To recap, the ratio between the final image and the initial image is the same from AB prime to AB, and AC prime to AC. So that means that this triangle is similar, except we don't know the third side. We've only proved this, proving that all 3 sides are proportional, but we also have, oh, all this work. Okay, part C, but this is all part C. All we have is an angle that is included in the side, and we have proportional sides. So we only have 2 sides that are proportional. Compare the corresponding side. What do you notice? What do you notice? You can write that down. You can write down, and I'll say it in words, so those of you that don't have headphones, that we proved the 2 sides are proportional, and they have an included angle that is the same. So these two triangles are similar. So this last part here, it says, based on your work in parts A through C, draw a conclusion about the relationship between those two triangles. Explain your reasoning. So we are going to say this: the two triangles are similar because they have a side that is similar, or if that is proportional. Side. They have an included angle that is the same, and that's angle A in this case. Okay. And they have another side that is proportional. So, side angle side, the two triangles are proportional. That's our exploration problem. Bye for now.